Gabriel?
Yeah, it's recording now.
Oh, okay, thank you. Okay, hello everyone. My name is Adi. I'm the IEEE Seneca president. I'm just going to introduce you what is the IEEE, and we're going to start the presentation. So basically, one of the main things that we are doing is creating a workshop for students. Like today, we're doing OrCad, we're doing all kind of workshops. You can see everything on our website. And if you have a request to do a workshop, you can just email us and we're going to try to create a workshop on the same subject, something that will help students. OrCAD is something that a lot of students are using. So this is why we keep doing the same workshops. That is the basic and the advanced. So I'm just going to show you a few slides about what is the IEEE. So the IEEE, we have more than, basically it's the Institute for Electrical and Electronic Engineering. It's a global institute. Worldwide, we have more than 419 members, over more than 106 countries. There is more than 100,000 student members. I'm pretty sure that the number today it's higher. There is a lot of documents that you can read, a lot of research that are free for members. Some that even if you're not a members, there is 39 technical societies and 7 technical councils representing the wide range of IEEE technical interest. Some of the benefits that you are getting is you join for a community that over 420,000 technology and engineering professionals. You can network with them. You can communicate with anyone from the IEEE. You can see here all of the benefits. I open it here also. So if you become a member, you get the IEEE magazine and all kind of information that you can access. You see there is all kind of societies that you can join through the IEEE. Okay, you can. I'm going to send the page on the chat so you can see it by yourself. I assume that everyone subscribed already for our mailing list. If not, I'm going to also add it on our chat. We send in emails just about our workshops. So if you're interested, just subscribe. We don't sell anything else other than workshops. And you can get an IEEE membership. I'm pretty sure that you still can get a 50% off because of COVID time. So they give 50% off. It's a few dollars a year. It's not really expensive membership. And I'm going to show you the website, our IEEE Seneca. If you just Google IEEE Seneca, you can get to this page. We're all over Google. If you want to subscribe, you just press here on the newsletter and put your information, and you can subscribe to our mailing list. And you can see all of our events. We're trying to do at least 2 events a month. Okay, so here you can just see all of the events that we have. And if you want to join us to volunteer in IEEE, you could just come here to join us. There is areas that we need support. If you want to do something from here, you're more than welcome. We especially want more people to do workshops. So if you know someone that can do a workshop, tell them to contact us. There is here, if you want to contact us, the information about our email. You can send us an email. I'm available all the time. And I think that that's it. I'm going to send all the information on the chat. And now Agastip is going to start the OrCAD workshop. Thank you, guys. Agastip?
Yeah, thank you, Adi. Thank you for the introduction. So, good evening, everyone. So, I will be doing the presentation for the OrCAD today, and it will be the basic presentation. So what it will cover, basically, I will do some basic introduction that what is OrCAD, why do we use it, then some of the different similar programs that we use, and then I believe that all of you guys are from first or second semester. So I will be building basic electronic circuits like resistors or voltage current divider. And then we will be doing the simulation. Simulation means that after building the circuit, I will try to run voltage current through the circuit to see that how does my circuit is behaving. So yeah, so I want this session to be interactive. So whenever I ask any question, please answer it either through in the chat or either unmute yourself and answer. So it will be a nice session, I believe so. So let's start. So I will start with the introduction. So what is an OrCAD? As you know that we are in a COVID now, right? So we can't get full access to the Seneca labs where we can go to the lab and we have a breadboard and the circuit components and we can actually build the hardware, and then we can pass the voltages, uh, current using DMM, using function generator. But those all lab equipments we don't have at our home. So there is way to build the electronic circuits without the need of any hardware. And that's why we use OrCAD. So OrCAD is basically a software where we can build circuits and then do the simulation. Simulation means that check that how is my circuit behaving. Then after that, we can design a PCB based upon that simulation. So whenever you see any PCB is a green color board. It follows a particular procedure to design a PCB. First, we will always design schematic. Schematic means there will be some connections in the drawing sheet. I will show you now. So if I go to OrCAD, so can you guys see my screen or no?
Yes, we can see it.
Okay, so I'm talking about this is the particular procedure of designing any electronic circuit. First, we go through schematic. First, we make a schematic of the electronic circuit. Like we will make connection that this is the resistor value, this is the voltage, this is the capacitor. We like basically whatever we do on our breadboard. So schematic is like a breadboard on the computer. Then there is PSpice. So this is a part of the OrCAD. PSpice means it will do the simulation. In here, we will give some voltage. It can be DC, AC, or it can be any frequency. So it will pass the voltage and study the behavior of the circuit, that how does by applying this much voltage, what is the output of my circuit. And then after that, when we have designed our circuit, we know that we have these connections and we have this output, and we are sure that we built our circuit correctly. We can start building our PCB. And then after PCB design, we solder the components. After that, we do the programming of the if there is any microchip on the board. And after that, we do the testing, final testing, and that's how all the PCBs are built, all the electronic circuits are built. First they start with the computer, first they start with the software. These three parts are software, and then this is the hardware part where we solder the components, and then the programming. So now I will go to the OrCAD. To access the OrCAD, Seneca has a My Seneca apps through where we can access the OrCAD, and there are different types of OrCAD softwares. So here you see Capture, PCB Editor, PCB Router. So capture is the schematic. Like I told you that there are three different parts of circuit designing. So capture covers these two parts, schematic and PSpice. So with this with this particular software, we can do schematic and simulation. And to design the PCB, we have to use PCB editor or PCB router. So this is just the basic introduction. And then you might have heard about other designing softwares like Eagle, Ultium Designer. So basically they do the same job. So now I'm into the OrCad screen. So this is the OrCad schematic. This is the OrCad capture screen. This area is called schematic. So this is where we build our circuits. I already have built a circuit, but I will start from the scratch. So I will delete the whole circuit. To delete it, just select the area you want to delete and press delete. And I will start with the uh, basic tools that we use. So this is the schematic. And now suppose that I want to build a circuit which has a resistor of 5K and DC voltage of 5 volt. And yeah, and then there is a ground. So I have 5 volt going into my ground, and 5K resistor. So how do we do it? We have a library. So libraries, they contain the files which contain the components list. So I will show you here. To add any library, you go here and click on this button and you will see different libraries. Right now I already have selected the libraries that we use most of the time for designing circuits at Seneca. These are these four libraries most of the time, always: EVAL, eval, and source special. So I will show you the components each library contains. So eval contains mostly transistors or some of the basic and or gates. So you will see, okay, if I select any transistor. So to select any part, I will click on the part and it will pop up the symbol of the part that I selected. And if I want to add that part to the schematic, I will go to this button and it says place part. So I will press it and yeah, you just give a left click and you're good to go. And when you add a part to the schematic, the part sticks to your mouse. So let's say if I again select this part, right, place a part, I already placed the part, but it still has a transistor connected to my cursor. To remove it, just press escape. So this is basically how we do. And there is a shortcut to place a part. Instead of going there and pressing left click on place part, just press P and you might, oh no, oh yeah, here is the shortcut. So in the upper toolbar, go to the place and then go to the part and select the part you want. And yeah, there. So now I told you that we will be building the basic circuit which contains 5 volt DC voltage and 5K resistor, and then there is one ground. So what do I do? As I'm working with OrCAD for so long, I do know which library contains the resistor. So the second library, EVALLA, eval, it contains the resistors. So you will see if you scroll down the part list, you will see that there is capacitor, inductor, IRF is a transistor, and then there is a resistor. So we need a 5K resistor. So if I selected this resistor, and now you see the symbol pops up for the resistor. Now I need a resistor, so to place the part, I will press place part or just press enter. And yeah, I have one resistor and I only need one resistor this time. So I will press escape to cancel the to remove the part from my cursor. So now I have resistor, but the problem is this is 1K. I don't need a 1K, I need a 5K. So how do we fix it? So we go to the value 1K, we double click it, and then it says value equal to 1K. So now I said that we will be using 5K, right? So I will press 5 and then type K, select OK, and now you have a resistor of value 5K. This is same like a breadboard, just on the software. And now I have a 5K resistor, and now I need DC voltage. To DC voltage, you may assume correctly that source contains the libraries for DC voltage. So if I scroll down, it has a AC current source, DC current source, sinusoidal current source, and here you say VAC. VAC is a AC voltage and VDC is a DC voltage. DC voltage is a constant voltage. So we need a DC voltage. So I will place this part and I will align it with the resistor. And now I said, as I said earlier, that we need 5 volt DC. So same thing, to change the value, just click on the value and instead of 0, type in 5. So now I have 5 volt DC going in my circuit, 5K resistance. Now what do I am missing? Can anybody answer that? What do I need extra? Just type in the chat if you want. Yeah, in a way, switch is also possible, but we are missing the main thing. Yeah, ground, man. Yeah, good, Amandeep. So yeah, we are missing the ground. So always remember, like most of the time, the problem we face, we design our circuit correctly, but we forget to put a ground. And you might not understand, or you will be seeing that your circuit is correct, but you getting problems. So this is the most common problem, that we always forget about putting ground in our schematic. So to insert ground in schematic, you see this toolbar on the right corner. Go to the symbol of ground, just left click it, and select the first option, 0 caps in, and press OK. You will see the symbol pops up for the ground. Press OK, and now I have placed the ground into my schematic. So now I have DC voltage, resistor, and ground in my circuit. Now I just need to make connections. I need wires because I have a symbols on my, I have components installed on my breadboard, but I don't have wires connected them. To connect the wires, there are two ways. First, you can go to the right hand toolbar and select this wire, place wire option, or to do the shortcut, just press W for wire. So press W and the cursor will change to the positive sign. So to place the wire, first left click on the component that you want to wire up with the another component. So I will left click on V1, and now I want to connect it to the left end of R1. So I will go there and red symbol pops up and you do the left click again, and yeah, this is connected now. Now I need to connect, I have to complete my whole circuit because current always flows in a closed path. So I have to close my path. To close the path, I will select right hand of R1 to the ground. So left click again. Now R1 is connected to ground. So is my circuit complete, or I'm still missing something, or I'm still doing something wrong? Can anybody answer? Any guess? I'm just testing your ETY knowledge, like if I'm missing anything, if you're building even on breadboard, that what Did I forget something? Yeah, man, Amandeep, you're intelligent, man. Yeah, I'm missing the last wire to the ground because this is not a closed path. My current will start flowing from here, from the positive side of V1. It will flow to the ground, but it needs a return path because if the currents flow from here, the charge will drop to ground and then current will flow never because it doesn't have a return path to the negative potential of the battery. So always remember to connect the negative potential to the ground. So I will first press W to select wire. Then I will do left click and left click again. Now this is a closed path. Now I'm pretty sure that my circuit is correct. I have 5 volt going into 5k resistor. So using the Ohm's law, it means that V equal to I into R, voltage through the circuit is equal to current passing through the resistor, multi I into I multiplied by R. So current will be 5V divided by 5k. So it will be around 1 milliamp. This is my calculation. And this thing I did using my a theoretical knowledge of this subject. But if you don't know it, if you don't know the theoretical knowledge that what will be the value, you don't have to worry about. OrCad will help you. You just make a circuit. You can you just make a circuit and you can ask OrCad to do for you. OrCad will do the calculations for you. You just build a circuit and you run the simulation. It will give you the values at any point. That at if at this point, what is the voltage, what is the current at this point, what is the voltage, what is the current. So to do so, how do we do it? This is the part that I'm talking about. Earlier, we completed the schematic part of the circuit. Now I'm going to the PSpice, which will do the simulation. So I will select PSpice, new simulation profile. I will name any random, name, inherit from nothing, create, and new windows pops up. So this is the simulation settings. So here, what does it say? This is the analysis type. Analysis type, right? It is like that. How do you want to measure your voltage? How do you want to measure your current? So time domain means that with the passes of time, how is your voltage changing? It's the same like an oscilloscope. So that with the time, after 1 second, what will be your voltage? After 2 seconds, what will be your voltage? So this is a DC voltage, so it will not change at all. But I will just giving you the brief introduction what each analysis is doing. And then there is a DC sweep. In DC sweep, you are not using the time. You are using voltage as a x-axis. Earlier, we are using time as a x-axis, like with the passes of time, how is my voltage changing? Now we in the DC sweep, we are changing the voltage, and there are like there can be a multiple source, multiple voltages in the circuit, and we are changing particular voltage, and we are studying that if I change this voltage, how will be the voltages changes in the other part of the circuit. Then there is a AC sweep. AC sweep is like a spectrum analyzer. Spectrum analyzer means that with the change of frequency, how is my circuit behaving? How is my voltages are changing? How is my current changing? So if at 100 hertz, there might be different voltage. At 1000 hertz, there might be different value. So that's for the AC sweep analysis. Then there is a bias point. Bias point is basically it will not show you any voltage. It will not give you any graph. It will just give you the values on the schematic window. Most of the time we use time domain because we are familiar with this. As I said, that this is similar to the oscilloscope that you see in your labs at Seneca. So I will select time domain, and this is a run to time. This is a DC voltage, so it doesn't make any sense that whatever time run, it will not change at all. But if you want, I can increase the time to 1 second. So it will run for 1 second, start saving data after 0 seconds. So my data will start right after when I press click. And it is a step size, like if I want a zero point 0.5 or after like multiples of which second, like 0.5, 0.5, 0.5, or if I select 0.2, then it will be 0.2, 0.4, 0.6, 0.8. So this is just the step size. And then I will say apply. Okay. Now I will press run pspice. So I have edited my simulation. I have given the values that I want to run my simulation for 1 second and with the time. So I will just press run pspice, and you will see there are some voltages pops ups here. So this is saying that that at this point there is a 5 volt, and here it is a 0 volt, and it makes total sense that this is a ground. Ground is always 0 volt, as we know it is a reference, right? And we gave 5 volt DC. So there is only one resistor, so all the voltage will drop through this resistor. So this is 5 volt, this is 0 volt, so we don't have to do any calculation. OrCad is doing all the stuff for us. And then if you want to see current, you press this enable bias current, and it will give you the current value. So this is 1 ampere, 1 milliamp. That's what I calculated using Ohm's law. So if you don't know Ohm's law, don't worry about. Just come to the OrCAD, build the circuit, run the simulation. It will give you the result. And if you want to know the power, just press this button. It will give you the power value also. And if you don't need any value at all, just unselect all the options. And now this is on the schematic. What if you want to see a graph? Now here it's just giving you the values, but if you want to see a graph that after 1 second how will my voltage looks like, you have this option. So this is the plot. This is the simulation setting we did earlier. So here the graph will pops up. To make a graph, first we have to use these probes, same like oscilloscope. Whenever we use oscilloscope, we have to select probes to the particular resistor to particular point to measure, right? So this is for measuring voltage. This is voltage differential. Like if I select this, there is only one probe. It measures the voltage with reference to the ground. What if we have a two resistors and I don't want to measure it with respect to ground? Then we can use this particular differential, and it will measure across the particular resistor. So now I have a probe. It is measuring the voltage across resistor R1. I will go to my simulation window and see how is my voltage. Yeah, you can see that my voltage is 5 volt. So my whole voltage is dropping across resistor R1. So this simulation is correct. So you get the point, right? So to generate, first build a circuit, then make a pspice file, create simulation profile, decide the time. I decided it to be 1 second, and you can see that it run for 1 second, and add the probes to the resistor or to the capacitor you want to measure, and just play with it. Now you may say that I don't like the background, and maybe the traces are so small. How do we fix it? How do we customize it? To do so, just go to the tools, then select options, and here you will see lot of options to use cursor size. So to change the cursor settings, these are the options. Like you can decide the width of the cursor, that I want it to be little thick. Select OK. Oh, I selected the wrong cursor. So go again. Cursor setting. Okay. So this is the cursor. Leave And so this is the cursor. So you see this is so thick now. So if I change it again, options, cursor, small, okay. And now you can't see the blue one because I decreased the size. Mhm. So yeah, this is the blue and this is a red cursor. So I will come to what is the cursor. So before that, I will show you how to change the background color. To change the background color, go to the color settings. Here, this is the background. I like mostly to be the white, my background to be white. So I will select white background. And yeah, here is my background with the white. Now you will say that I have a graph, right? So I don't want to go to the schematic and see the values. I want to study that how is my voltage looking at particular time. So here is my graph. So I want to see that if at 0.2 second, what is my voltage. So that's the purpose of using cursor. So when you select cursor here and press left click, you will select one of the cursor. Now I have selected cursor with the left click. And if I move the cursor around, you will see that there is this window down there. It's changing. It's changing. The reason is that it's showing the value of y at particular x. So if I go to 0.4 second, you will see here x value is 0.400 milli, so zero point 0.4 second basically. And the y value is here. Y value is my voltage, right? So my voltage is here 5 volt. So this is correct. So what is my voltage at 0.5 second? So my cursor is zero point 0.5 something, right? And the value is same. So because this is a DC circuit, so that's why. So yeah, so this is just the basic introduction to OrCAD capture. So this is the schematic. This is the PSpice. So up till this point, if anybody has any question, just ask in the chat or just unmute use yourself and ask me any question.
Yeah, Akashdeep, fantastic, great job. Okay,
Thanks.
so let's everyone give a virtual round of applause to the Akashdeep. He is spending his time. He and his Gabriel here is giving you a lot more informations. And special congratulations to Akashdeep for getting a job. Let's everybody give a huge round of applause to virtual to the Akashdeep. Fantastic job. Okay, Akashdeep, congratulations for getting a job and you're helping this everyone. So that's absolutely awesome. We're really proud of you. What you are doing is really absolutely amazing. Keep on doing. You know, I can't wait to have a party. Balle balle and samosa. Okay.
No worries, Professor.
Very nice.
Thank you, Professor.
Yeah,
Thank
yeah.
you.
Yeah, thank you. Thank you. Thank you for adding a lot of value to all the people. So I will
No,
be in
I
and out.
really enjoy teaching. Like, it's like sharing the information, what I did through my student life, and we suffered a lot. Like, we don't have a proper guidance, but you help us a lot.
Yeah.
So this is what we need to do. And even the Gabriel, he is investing his time. So yeah.
Yes. Yeah. Yeah. We
I'm
truly
just
appreciate your and Gabriel effort. Next time we are going to start. We will put it that workshop on the first week only, so the people do really start catching up. So in the fall, we are arranging such a way ahead of the time. Gabriel, I'll let you know. So in fall, we are going to do in the first week itself.
Okay.
Okay. All right. Thank you, Akashdeep and Gabriel. What you are doing is a great job. We're really proud of you. Keep it up. Okay. And you're explaining very thorough, Akashdeep. You became better and better compared to the first time. You're getting better this time. Okay.
I guess so. Thank you.
All right. Best of luck. Okay.
Yeah.
Thank you.
Thank you.
So any question that whatever I have spoke up till now, I will continue to the other complex circuit, or you guys can comment out that which circuit you want me to build. I will build that circuit. or if you have any doubt in mind that this particular circuit, how do we design it? Because we have a time